Hi, my name is Julia Silke, and I am a data scientist and software engineer at our studio. And today, apparently, I'm joined by one of my cats in frame there. And this video is about tuning hyperparameters, specifically for a random forest model, but this will extend to other kinds of models that have hyperparameters that you can tune. This is a model that is about more advanced topics. I'm excited about how to show you how to use the tidymodels sets of packages for how to take on some of these bigger tasks. And in this video, I'm using a Tidy Tuesday data set from earlier in the year about trees in San Francisco. And we're going to build a classification model to predict the status, the category of these trees. So let's dig in.
Okay, let's get started. So today we're going to be dealing with a data set of trees. Trees that are in San Francisco, and this is actually a Tidy Tuesday data set, but it is from earlier in the year. It's one I've been interested in exploring, so I am excited to get started with it and be able to show what to do. So today's video is a bit more of an advanced topics. We're going to be exploring this data set of trees here, and we are going to build a random forest model with it, tune the hyperparameters of the random forest model, and then explore some of the results that we get out of it and show how to choose the best model and how to get the best model out and work with it here at the end. So this is a shows kind of some of the more advanced things you can do with tidy models, which is exciting. So less of a getting started and more of a what are some of the more advanced things you can do with tidy models. So let's look at this here. So this is a data set of trees that are located in San Francisco. You can check out the website, the website here on GitHub to see in the README to see what's in here. But we've got a tree ID column. We have info about the legal status here, and the largest legal status is DPW maintained. So this is the Department of Public Works maintained, and that's the biggest one. And there's all these other different legal statuses of these trees. So is it a permitted site tree, or is it a significant tree? Don't worry, trees, you're all significant to me. Is it a landmark tree? Is it NA? So what we're going to do with this data set is we are going to build a model that is going to predict. It is going to predict the legal status. We're gonna build a model that is gonna predict when it is this majority case, this Department of Public Works maintained legal status, and all the rest of the time we're just going to call that other. So we're going to say, can we build a model that can find these trees compared to all of the other trees? That's what we're going to do. So let's look at some of the other things we have here. We have species. Let's just kind of look at what we have here in species. So we've got a lot of species here. I'm going to show how we can deal with that in with a recipe step later. So we're not going to do anything with that right now. You can see some of them it is not specified, but for a lot of them it is here. So we are if we don't have info on the species, we're just going to leave that. But then for all the things that we have, we're going to show how we can keep that information for the ones that we are interested in, and then above some threshold, and then change the rest to an other category. We have address. We are not interested in because we're not going to use the address because that is too much like an ID column, so we don't want that. Site order, if you look at the README, is how many trees are at that address. So there, there's 3 trees at this one address, and that is kind of interesting because if there's, I think that might be, let's keep that in the model and see if there's more than 1 tree at an address, is that more likely to be maintained by the Department of Public Works. The site info, I think, is interesting. Let's see what we can do with that. Site info, like so. So sometimes we don't have any, but and there's definitely a majority case here that's much bigger than the others. So let's see what we can do with that, if we can use that in the model. And then caretaker is interesting. Let's take just a quick look at that here. So private Department of Public Works, and then the something to do with SFU, Rec Park. But if you notice, it's not always. So if we say legal status caretaker, so these there are a lot of in fact most of the Department of Public Works maintained trees are taken care of by private individuals. So this combination here is not, they're not it's not the same. It's not like, oh, those things always go together. So the caretaker information we would like to use in the model, but these are not measuring the same thing. They are not always, so a caretaker and the legal status are not measuring the same thing. And what else do we have? Oh, this date. So I would like to use the date. That's the date that we have when we have something about when it was planted. So I would like to use that, but we're going to have to build a feature from it. So we'll do a little bit of feature engineering. This is a measure of the at a certain height, the diameter, and we've got a lot of NAs in there, but this data set is very big here, so let's filter down and see if we had that information, is it helpful? So we're gonna let's keep that, and let's add a step here where we're gonna do NA omit like this, because let's not try to do any imputation here. Let's just get rid of cases where we don't have that information. And then the latitude and longitude, let's definitely keep those and see if we can build a model from that. And that's part of why we're getting rid of address, is because we have latitude and longitude. We know where these things are. And then let's look at plot size. Select plot size here. Let's put in the NA omit first. Like this. Okay, so we have info here that's is a character because it is encoded in different ways, but it does have a number here, and they're in different orders. Sometimes the big number is here. I bet that sometimes the big number is second. Yeah, sometimes a bigger number is second. Maybe these plots mean something in terms of what's by the street, by what goes backwards. I actually don't know. Like maybe one is width here. So this is not going to be perfect, what I'm about to do, but maybe we can get some information from this. And what I would like to do here, just so we don't throw this information away, so we can see if this is informative and if we can use this in a model, is what if we said plot size, and let's take this and let's do a parse number plot size. And what this does is it basically it goes and it will take the first thing it finds. So it will skip over width and find 3. So it will ignore 25 and it will find 3 here. And we end up with a numeric value. And you can see sometimes it couldn't find anything, so it'll end up with an NA. So we can filter those out again. There's a lot of data here, so I think that will be okay. But so let's try that. Let's see what result we can get from there. Another option would be to not try to use this in our modeling, but I would like to try. So let's add that here. So let's do this this business here. Plot size, parse number, plot size. And yeah, and then so we're going to get rid of everything we don't have NAs with, rather than try to impute values here. And then anything that is a character, let's change to a factor. So this is because we are going to be doing some modeling, and modeling, we would like things to be in factor values. All right, so there's those same parsing failures that we got before, which is not unexpected. All right, so we've got our tree ID. We've got, this is the thing, this ring right here is what we're going to predict. And then these other columns is what we are going to use to do the predicting. So let's just make sure we got what we expected here by using skimmer to take a quick glance. So we have a date variable. We're going to have to do something with that because we're gonna train a random forest model, and it's not going to be very happy with that column as is. So we're going to create some features from the date, do some feature engineering. We have several factors here. This is the first one we're going to be predicting. You can see that the positive thing is much more common than the other case. And then we've got these species. There are 320 species in here. That's a lot. Site info, we've got 19, caretaker 20. These are factors with a lot of levels in them. So we will probably are going to want to do something with that to figure that out. Okay, and here are the numeric things. This is an ID column, so we will not use that for modeling, but we can carry it around with us if we would like to help look at things later. We have site order. Remember, is it the first tree at that address or location, second tree, third tree? This is the diameter. Those things are all distributed, very much piled up at one end. And then latitude and longitude here are distributed in this way. This is kind of a fun data set because we can make a little bit of a map. So let's take, let's do that. Let's look at how these things are distributed. So this is San Francisco. So I always have to stop and think which goes on X and which goes on Y. So longitude goes on X, latitude goes on Y. And let's color these dots by their legal status, like so. And let's put a bunch of points. Let's make them see-through a bit so we can see where they are. And then I don't think we're going to need the label on that thing that we're looking at here. Okay, those are a little big. Let's make the points smaller, like this. Okay, that's better. Let's make this a little bigger so we can see what's going on here. Okay, so this is a map of San Francisco. This over here is Golden Gate Park, this blank spot. So apparently none of the trees in Golden Gate Park are in this data set. And I can look at this, and this is pretty interesting. It does look like there's some geographic difference in how these two kinds of trees are distributed. There's a lot. It looks like the coral is more common over here. Looks like there's more blue over in this central section, maybe up here. You can definitely see where there are some streets and things in this data set, which is pretty interesting. Making maps is always so fun and so interesting. Love to make maps. Everyone loves to make maps, which is cool. So this is cool because it's a data set where we can do that, and we can actually use the latitude and longitude in the modeling. And we are going to build a random forest model, which is a tree-based model. And so we're going to be able to learn interaction. Like the model will be able to learn thresholds and interactions without us explicitly having to put them into the model. So this is not like a linear model where we're saying, oh, there's going to be something smoothly varying from one side to the other, or from up to down. We're going to be able to learn the idea here is the random forest will grow these complex trees that will be able to learn as best as it can whatever kind of behavior it sees in this and other characteristics of this data about the trees. All right, okay, so we do have other characteristics. So let's check one out. Let's look at the before we start building our model. Let's look at the caretakers. So let's see. So we've got the trees. So let's count legal status and caretaker. So let's see what that looks like. Let me put that back down. So we've got legal status and caretaker here. So there's a lot of caretakers. We've got, the health department and the arts commission and so forth. And let's make a quick visualization to look at the top ones. So I'm going to filter down to just the top caretakers. So I'm going to do this by adding a count. I'm going to add what column I would like to count up is caretaker. I would like to add up with a weight. The weight here is going to be the column N. And then let me give that new column a name. So let's call it caretaker count, like this. So now I have a new column. So there are 11 trees in this data set that are taken care of by the Arts Commission. 6 that are DPW maintained, and must be 5 that are not. There's only 2 trees that are maintained by the City College. So I want to let's try 50 here. That's nice. Okay, so we've just got 6 now. 6 caretakers, which seems pretty decent. And now I want to see what proportion of the 2 categories of trees belong to each of these different caretakers. So let's before I mutate, let's group by legal status, by the category we're going to be building a model for, and then let's say percent legal equals n divided by some n, like this. And so now we have what proportions of these different 2 categories, the positive and the negative side, are from these different categories. And then let's just pipe that straight into ggplot, and let's put the percent legal on the x-axis, caretaker on the y-axis, and let's make 2 bars. We're going to make 2 bars and call that legal status, so that we have the 2 bars next to each other that are the 2 different categories. And so I'm going to use geom call to make this bar chart, and I'm going to say position equals dodge here. So let's okay, so that worked, and that okay, so that's interesting. So there are some big differences. Actually, they all look quite different. So the caretaker DPW is much more likely to be a DPW maintained, but actually and private is a higher proportion of the other. But remember that before that there were more that were there are a lot that are private that are DPW maintained. So, and we see differences in almost all of these. So I bet that will end up being important in the model. So this helps us understand all the things that are contributing to in the different ways that these two different kinds of trees are distributed around San Francisco. So let's start building a model. Let's build a model that will take advantage of all these different kinds of characteristics that we have, and be able to train it and find out what they are. So we're going to load the tidymodels framework. So we're going to use tidymodels for our modeling today. And the first thing we're going to do is we're going to split our data into test and training sets. So we're going to set a seed. So I'm going to do initial split. I'm going to use that trees DF data frame I made, and I'm going to do stratified sampling here, and I'm going to stratify it according to that that category that I'm going to use for modeling. So let's call this trees split. So this is going to be my split here. So trees split, like so. So this says of all the data you have, I'm sorry, this side, all the data you have, here's the data that goes into training, here's the data that goes into testing, and then we can get those, get those data sets out using the training function and the, let's see, let's do trees test, the testing function, trees split like this. So now we've got these guys. So trees train has almost 18,000 rows, and trees test, did I say train? So this is a training data set, almost 18,000 rows. This is the testing data set, almost 6,000 rows. Okay, so we've got, this is the training and testing sets that we're going to use for our modeling. And next, let's do our data pre-processing. So we use recipes for data pre-processing. So the first thing we do is we set up a recipe and we say, let's define what our model is using a formula. So we're going to say legal status explained by everything else, and the data is this trees train data. So this is the beginning of our recipe, and let's look at that trees train data. I'm gonna make that go away like this. So here's trees train. So let's start thinking about some of the things we're gonna have to do for pre-processing here. For starters, let's look at this thing here. That is a ID column, and you know, I'd like to keep it. I don't want to maybe get rid of it, because what if I want to join back up later, or update, or explore something that's particularly interesting. So instead of getting rid of it, I'm just going to update its role. So I can do update role. And I say, what column do I want to update the role for? And then I say new role, and then I say something. So what this does, it says this column, instead of being a predictor, which is this thing, or an outcome, which is this thing, or a predictor, which is everything else. This is now a new thing, an ID. So don't use that in the model when you use the recipe for training. So that is, so that's good. And now let's talk about some of these things that had like 10, 20, or hundreds of levels. That will take a super duper long time to train. And this is already a lot, this is already a fairly big data set. And so I want to start making this problem a little more tractable. We're going to use Stepother for that. So Stepother, like so. So what Stepother does is it collapses categorical levels. So let's look at, so there's 3 here. Species, site info, and caretaker that I want to do this for. So you can put in the columns that you want to do it for, and then threshold like this. The threshold you want to, you can change it. You can specify in different ways, but it's like if something is below some threshold, if the rate of occurrence, then you're gonna change it to other, and just put it all together in one factor here. So let's do that. So let's say Stepother, and let's say species, caretaker, and site info. And let's see, so the threshold is 0.05. I don't know, let's see what happens if we do 0.01. So let us I'm going to need to look at the output here. What will be the best way to do that? Let's say, so here's the recipe, and then we can prep it. So remember, what does a recipe do? The recipe just specifies what is going to happen when we prep it. Tree prep. When we prep it, we actually go to the training data and we learn what these things should be. So the prep. I'm not going to remember otherwise. So after it has been prepped, it actually says, oh, okay, I actually prepped those things for you. And so if I want to get out, let's see. So then the way we get it out, let me get the juiced and juice. So now I can get out the results here. Juiced. And for example, now I can say count, for example, species sort equals true. And now I have 25 species instead of, remember, it's like 300 and a lot are in other. And that seems about right to me. Let's see what happens with caretaker. Okay, 5 now. And those, I looked at 6 in that plot. This seems okay. That seems okay. And then let's look at site info. Site info. 3. That doesn't quite seem okay. Let's make another step. So we're just going to take site info out of here and only do site info here. And instead of, we're going to make it half as much. What happens if we take it a little bit further down? That seems, because let's see, this is all sidewalk. Oh no, there's one median, sidewalk, and now I get one front yard and one like no info. I don't know. Either one of these is fine. I'm gonna go back to 0.5 here. There we go. We're gonna do that. Like so. So if I'm making choices about data pre-processing here, and if you're like, why is she deciding those things? How does she know? That's a really good point. And these actually are things that you can change. You can tune. We're not going to do that now. We're just going to tune the hyperparameters of the model. Okay, so we did that step other. Next, let us, we are going to change all of these to numeric. So we're going to do a step dummy. And so we're going to do, we're going to change all of the, all of these guys, all of the species, all of the, all of everything into dummy variables, except we're not going to do it for the outcomes like this. And so now if I do juiced, it's gotten so many, look at all those columns, so many columns. And the next thing I'm going to do is I am going to look at that date column, because Ranger, the engine I'm going to use for random forest does not like this date column, and it wants it to be in a numeric form. And you know what? Like, these are trees. They grow slowly. I don't think it matters whether a tree was planted in March versus it was planted in May. So I am gonna do a little of what we like to call feature engineering for these trees. So I'm gonna use a function called stepDate, which takes the date. So this column is called date, so that's why I'm passing it here. And then I'm gonna say, make some new features here for me. Actually only make one new feature for me. So I could do a bunch, like I do like month. Were trees that were planted in March different than trees that were planted in July? No, that's silly. I'm not gonna going to do that. I'm only going to do year because these are trees that grow kind of slowly. And then after I do that, I am going to do step RM, and I'm going to remove the date so I don't have this anymore because I don't want to have that. I only want the year. And so after that, it will be a numeric value, which is good because that's what I need. The last thing I'm going to do is I'm going to downsample this data because it is currently pretty unevenly balanced. There's a lot more of there's a lot more of the of these. Wow, so many more. I don't want to do that. I'm going to downsample it for training. Step downsample, and I'm going to downsample legal status. All right, there we go. Gosh. I did it. All right. So this is now the recipe that I'm going to use. So that's a fair number of steps here. But this data, you know, it's a little bit more complex, and so that's okay. So these recipe steps have been saved in tree recipe here, but they have not been trained yet. So this, if we need to go and know what the steps are without them having been trained, this is the object we want. If we want an object that knows about the training data and has it already done, we can go to tree prep. So prep is the one that has actually gone to the data and done something with. Okay, so that's our pre-processing. Now it is time for us to make our model specification. So I think I've mentioned this already, but the plan here is to build a random forest model. And for this random forest model, you know, random forests, they're pretty great out of the box, right? Like they do pretty well, but they do actually have hyperparameters that you can tune. So the first one that can be tuned is mtry. So let's look and remind ourselves what these guys are. So mtry is when you get, so when you're splitting and making all the like leaves of the tree, how many are you gonna take? How many are you going to sample at each split? Are you going to show all the predictors, or you know, a few? And then the other that for a random forest, the number, you just need enough trees. Tuning trees doesn't have a huge impact. You just want to have enough. And then the other thing that you do want to tune a lot is make sure you tune is min n. And min n is when basically how long do you keep splitting? How many data points have to be in a node for you to keep splitting further? Like when do you stop that? Okay, so this is, if we just put one number here, it would train, we would be setting up a model specification that could be trained with that value. But we're putting tune there, saying, hey, I'm setting up a model specification, but I want to figure out the right value for this for my data set. I don't know what it is yet. All right, so for a random forest, there are a few other things we have to do. We have to set the mode, because random forest can be used for both classification, which is what we're doing here. We are predicting legal status. Does it belong to the, is it maintained by the Department of Public Works or not? And then we also have to set the engine, because they're, you know, random forests in R, you can do a bunch of different ways. And here we're using the Ranger implementation, which is great and fast. All right, let's call this tune spec. So meaning it is a specification, a model specification here. So like so. Did I do something wrong? There we go. Okay, that is more how I was expecting it to look. Okay, so let us set that. So this is, I'm just defining. Right now I'm just defining what the model is going to be. No fitting is happening yet. the next thing I'm going to set up just for convenience is a workflow, because it's easier to pass things around in pieces this way. A workflow is a set of convenience functions for passing around different pieces of your modeling workflow. You define, hey, I'm making a workflow, and then you add things to it. For example, I'm going to add my recipe, my unprepped recipe, and I'm going to add my model here, which is this this tuned specification here. And let me call this my tune workflow, like so. And then let me take a look at it. So this is my workflow. So it says here's your workflow. The preprocessor is a recipe. It could maybe also say formula there. Here's your model. It's a random forest. Here's what happens in these things. So this is just a way to carry stuff around to make things easier. There. All right, so we have set things in, we have set things up, and we're ready now to start training the model. So we are going to, let's do tenfold cross-validation here. So we'll take v-fold CV, and we will send it to the trees training data. Let's call this trees fold, like so. We definitely need to set a seed. Let's see, I think I had 1, 2, 3. Let's do 2, 3, 4, like this. Okay, so let's look at these guys. So, whoops, nope. Trees folds. So we have 10 cross-validation folds, and this is the amount that is in the analysis part of the fold, and this is the part that's in the assessment part. So we will train here, assess here, train here, assess here, and so forth on down all down the folds. And all right, before I forget, while I'm thinking about it, let us set up parallel processing, because this is a pretty big-ish, data set, at least for a video, for a screencast, and for me to be just sitting here, that's for sure. And let's while I'm thinking about it, let me set another seed. Let's do 3, 4, 5. So we're gonna do a tune grid. So we are gonna tune these parameters here, m try and min n, on a grid. Let's just do like the grid that we don't say anything special about where it's going to be. So what we are going to tune is we're going to tune that workflow that I set up. The resamples are going to be these folds. So what are we tuning? This workflow. What are we tuning it on? This data. And then let's just so we can get a good look at things, let's do 20 points that we are gonna tune this on. All right, so I'm gonna get this started here. Here we go. And so it is getting started, and then I am actually going to pause the recording, because this takes a little bit of time, even with parallel processing, to fit, and then we will come back when it has finished. Okay, we're back. The tuning finished. We can look at the results here. So we have the split and the fold like we did before, and now we have the results of the tuning, the metrics, and if anything went wrong, it would be in the notes. So notice that we didn't keep those models, actually, because when you tune, you don't actually like keep the fit models around. You do, however, say for each model that we tried, what results did we get? And here we can say, we can say like, hey, give me the best accuracy. Select I did something wrong. Okay, we can say select best. Did I do it wrong? Let's see. So we'd say when we want to do select best, we say did I just spell it wrong? Accuracy. We would say select best metric equals. Yeah, there we go. So we would say select best. I think we don't collect first. Is that right? Yes, that's right. We don't collect first. That's what I did wrong. Okay, so we here, yeah, there we go. So in this case, this is what we did. We can get the best one, but I would like to see actually what was going on here and visualize the results that we get. So let's build a little bit of a visualization. So we are going to take that result that we had and collect the metrics. And let's make a plot of let's only make a plot for one of the metrics. So let's say dot metric. Let's do it for area under the curve here. And we're going to use ggplot2 to make a plot. And so I want to see, I want to visualize like what is the area under the curve for these different values of mtry and min n. So let's just take what I want to plot, which is mean, min n, and mtry, like this, and let's pivot. So right now we're in it's in a wide. It's in a wide shape. So like if I took these three things like this, it's in a wide shape, but I need it to be in a long, tidy shape. So the columns that I want to pivot are min and mtry, and I want to the values. I need to say a values to. Let's call that value. And the names to, and that's the tuning parameter that we did. So let's call that parameter. And I think this will work. Yes. So we have, so the value for area under the curve at this value, at these parameters and this value, like so. And now we have reshaped this so it can go into ggplot. So we'll say value is going to go on the x-axis, mean is going on the y-axis, and let's say color equals parameter, like so. And we're going to make, boy, I hit that a lot. We're going to hit, we're going to do points. I'm just doing color for clarity. And we are going to facet. We're going to facet by parameter, like so. So let's see what this looks like. These are they're actually pretty close, but they didn't have to be. The scales on the min n and the mtry didn't have to be on the same scale. So let's yeah, that's actually slightly better. Okay, this is interesting. So let's think about what's happening here. So this was not, this was just like a grid where that kind of moved all around in the, like this this two-dimensional space of min n and mtry. So let's look over here at mtry. It looks like area under the curve is low for low values of mtry, and then goes up, and then it looks flattish out here, but of course it's hard to tell because I don't know which values of min n were those. Min n, it looks like has a higher value of area under the curve at lower values of min n, and then goes down. But again, I don't know kind of how much of the jumping around is to which values of mtry. So this gives us a good idea, kind of a good big picture idea. This is helpful. I now know I kind of want to, I want to stick to the higher values of mtry and the lower values of min n. But I'm gonna have to tune again. It took a while. I had to step away and go get a coffee or something, but I guess I get to go have another coffee or another snack because I am going to tune again. I'm going to tune again using the information I have here. And instead of doing this, instead of saying grid equals 20 and doing this, this design of this kind of grid, I'm going to make a regular grid. And what this is, it's going to make a grid where we have where we get to say which where we have the same values, so that we can make basically lines where we can see, we can say, oh, at the same value of min n does m try, is it higher or lower, and we can get a better value of what we should say is our best model. So let's say, so we can put in these functions that are in tidymodels, in the dial function, and we say range equals, and then we put in what we want here. So let's see, let's look over here for m try. I'm going to start at 10. I'm going to start at 10 and then go up to 40. There, and then the next thing I need to do is min n, and we'll say a range there as well. And I'm going to start at the same thing, which is 2, I believe. And then how far should I go up? What if I go to 10? And then what happens if I say levels equal 10, like this? So what do I get here? Oh, 90. That will never work. I did 20. I mean, it will work, but I would be sitting here for so long. That was 20. Let's cut this down. What if I go to 8 here? That goes down to 70. What if I go down to 5? 25. Okay, that's doable. That's doable. There we go. I'm going to call this my grid. Let's call this my random forest grid, like here. So that is going to be my grid that I'm going to use. So let's look at this. Let's copy this here, and I am gonna let's keep going. 4, 5, 6. And instead of the grid, instead of just doing instead of it picking the grid before where nothing. I didn't, for example, try the same value of m try at multiple min n's. I am going to use this regular grid. So, for example, I'm going to try all the values of m try at the value for that 2 for min n and so forth. So I'm going to try this grid is going to be what I'm going to use now. And let's call this something else. Let's call this regular result, like so. And yes, so I think this is ready to go. So what we're going to do now is we are going to start this. Did I do everything right? I believe so. I'm going to start that running, and it is going to take about the same length of time because we're training about the same number of models, but that's still enough time for me to yet again pause the model. Pause the video, and while this model trains, and then I will come back once again when this model is done training. Okay, we did it one more time. We took this updated grid that that has these different values, this regular grid, and trained a whole bunch of models here with this grid, or tuned the value, or trained all the random forests so that we can now figure out which ones are the best. So let's go down here. So we can do, for example, this result. We can collect the metrics on this result in the same way that we've done before here. And like we did before, let us filter to the area under the curve. But instead of doing this pivot longer to a long shape and putting it like we have in this plot on the two lines next to each other, let's make some different lines of different values, because this time we train different sets of parameters here. So let's make let's see, so min n, 1, 2, 3. We've got, let's do min n, let's say min n is a factor now, instead of a numeric, so that we can make different colors with it. And let's do this. So let's put m try on the x-axis, the mean, the area under the curve on the y-axis, and let's make lines of different colors here. And let us put those points on. Let's put these points on right here. So, all right, that's looking good. Let's put a line on so it's a little easier to see, and let's make that line. Let's make it more transparent and a little big. That looks nice usually. Here. All right, good. This is looking good. Okay, so good. So let's remind ourselves when we didn't have the regular grid, we could see like, oh look, m try. We don't want it to be too low. We want it to be higher. And m min, we want it to be lower. And now when we make this plot here, we can see that that was the right call, but also we can see when we do a regular grid and we test every value, we can find what the actual best value is. And of all the ones we tried, it's this one right here, So what we can do, we're able to use that first set of tuning to kind of explore the space more largely, then zoom in a little bit and find a better set of what is going to look better here. And now we can find, of everything we tried, what is actually best. So let's put in that tuning result and find the actual best one, which is here. It's this a min n of 2, m try of 15 here. So let's call this best AUC, like this. And then we can use a function called finalize model. And what finalize model does is it takes a model spec. Remember that we have been tuning this model specification, and when we've been doing these tunings up here, and we can say, hey, let me take that model specification and I want to finalize it, meaning I want to update the parameters. So instead of I didn't run it. There we go. Okay, and so now instead of having the values for tune here, it goes in there and it says put in the values that we ended up finding were best. And now this is going to be our final value for the random forest here. So now we have a final value for we've gone through this whole process here, and we have found what are the best hyperparameters for this data set to be able to tune this random forest model to this data set of trees in San Francisco. We can kind of check out how did this go? What did we learn from this? And two things we might want to do is, I think let's do two things here at the end. Or a couple, I guess. First, let's look at variable importance. So we're going to use the VIP package for variable importance here. And we're going to take that final model spec, and let's set the engine. We have to reset the engine so that we can do importance. So that we can find the importance, because we have not been calculating the right kinds of things during the fitting process to calculate variable importance. And then we're going to fit it. We're going to fit it to the did I do this right? Legal status, explained by everything. And then the data we're going to set it to is let me remind myself. So reduce tree prep. Let's look at that. Tree prep. This gets us the training data, and the only thing we have to do is just get rid of that ID. So let's get rid of the tree ID here. So this is the this is now the training data that we're going to put in here, and then we can do a variable importance plot, and let's make a point here. So what we're doing is we're taking that final model that we made, we tuned, and we say, hey, take this final model and reset the engine so that it has the variable importance calculation, and then fit it to the training data, the whole training data at one time. And then we're going to make a point, we're going to make a plot that shows us variable importance for the top, I think it's like 10. We'll see when it pops up here in a little bit. I think, so this is a pretty big model still, so it's going to take us 30 seconds or so to fit. So let's zoom this in so you can get a look here. So these are what are the variables that have the biggest impact on the model globally. Whether that private caretaker has a big impact. I love seeing this. Longitude and latitude. So actually where the tree is has a really big impact, which is very interesting to see. How old the tree is, that is very interesting. Some more info on the caretaker. How big around the tree is. Okay, so plot size, and one of these species gets in here. So we can explore variable importance through a plot like this. So this is global variable importance for the model as a whole. So this is what impacts the how much impact these variables have on the classification, whether it goes one way or the other. Let's say we wanted to see how well this model did on the testing data. So we have, these where we say, okay, like the best AUC we got was 0.945 or something like that. What do we do if we want to go back to the testing data? So what we're going to do is we're going to take the same final model that we made. Now this time let's go back to workflows because it's a little bit more convenient, and let's add that same recipe that we had before, and then let's add a model. In this case, instead of adding that tuned model, we're going to add this final model, and let's call this final workflow, like so. And so our final workflow looks like this. It's the same recipe as before, but now we have, instead of tuning values, we have these final values that we got to. And what we can do is we're going to use a function called last fit. So let me show you what last fit does. Last fit, so this is for when you've done tuning. So last fit says, take your final best model and fit it to the training set, and then evaluate it on the test set. So this is a nice little convenient function. And what we can do is we can take our final workflow and we can pipe it to last fit, and then all we have to give it is the split object, because it needs to know about what is the training data and what is the testing data. And then it trains the final model on the training set and evaluates on the test set to know how well we're doing. So let's call this final result here. So let's do this. So this is also going to take 30 seconds or so. And what we will do here is we will do collect metrics, and the metrics that we will collect here will be on the test set, and we can look and see how do these final test metrics look. Do they look like we overfit, or like it looks about right? And so our final ROC is looks great. So we did not overfit to our training data during our tuning procedure. So that is excellent news. And this is about the kind of area under the curve we would expect to see when we when we applied this model to new trees, when we found new data about trees in San Francisco, we would expect to see about this same area under the curve. All right, one last thing before we go. This video might be getting a little long, but this will be fun, so let's do it. So let's look at that final result. What's in it? It has the split metrics, which is what we just looked at here. The predictions. Let's look at those predictions. So this result, if we do collect predictions on it, this is actually the predictions on the test set. Remember the test set? Boy, we haven't looked at that in a real long time. So this and this test set, same thing. So if we bind those together, bind them together here, let's you know what, I want to make one more map, and I want to make a map and see what is the spatial distribution of things that were classified correctly, and the things that were classified incorrectly. So let us let's add a little new column here. So we'll say something is correct when let's use case when legal status is equal to predict class. Let's call that correct. And all the rest of the time, let's call it incorrect, like so. So we can bind all these things together. And here is, whoops, I forgot a pipe. Try that again. Here, and so this one's incorrect, this one's correct, and so forth down here. And then let us go back up here to what makes a map. Paste it in, and instead of color being legal status, let's make color correct. And I'm going to use a different color just so it's not confusing to anyone watching this video that I'm looking at something different. Let's make it let's make like a light gray for the correct, and then incorrect, I don't know, dark red maybe. Let's see what this looks like. Okay, let's just make it a little bit darker. Not quite so transparent. And let's zoom in and take a look at this. All right. Okay, I think this is quite interesting. So there does seem to be some spatial patterns in where the model is more and less correct. Maybe some east to west differences, maybe some other sort of features and areas where the model is more likely to make a mistake. And so we're able to explore that using the data that we get out the end, and use the tools like ggplot2 and dplyr that I and many of us are familiar with. So this is the last thing we want to look at, and I think I really like this this whole exploration data set. It is a bit more involved, a bit more advanced, but I think the results that we see here are really nice.
So that is that. You can see that my cat is still cozy, and that was quite a project that we worked on. I love looking at those maps of where the trees are around San Francisco, and we tuned one time. We tuned the hyperparameters of the random forest model one time using more like the defaults to kind of get an idea of where those hyperparameters should be for this data set, and then we used a regular grid to be able to be more certain about what the best hyperparameters for this particular model would be. And then we use some great convenient functions from tidymodels, specifically in the tune package, to be able to get the final fit, the final model that we wanted to use, and then to be able to assess how well that final model would do on the test set, and then get a final model that is then portable that you can use later in when you need to predict on new data. So that is that, and I will hope to see you next time.